Hello engineers, welcome to a new video on low-level design. In this video, we'll look at the chain of responsibility pattern. I hope you're ready. Let's get started. So this is the intent. Avoid coupling the sender of a request to its receiver by giving more than one object a chance to handle the request. Chain the receiving objects and pass the request along the chain until an object handles it. So this is the intent. Let's try to understand this with an example. Let's use the authentication setup. Right? Let's say I am a user and I want to access my company portal. Let's say this is my internal company portal. Okay. I am trying to access this website. So let's see the things that are required for me to access this company portal. So the first step is to verify myself as a user. First, I will give my email. Then the server verifies if this email exists or not and if the email is actually within the company. So I verified by email. And then my password needs to be verified. I provide some password, it will be validated against the database, and then I will be passing the gate of password validation. After that, I will pass the gate of RBAC. RBAC is nothing but role-based access control. So every user will have some role. So HR people will get access to HR websites, employees will get access to the attendance portal, payrolls, etc. Finance team will be able to access the payroll in an edit mode, etc. So there will be different users using different pieces of the company portal, right? And as a general employee, let's say I am getting access to my attendance portal, right? So in order to access the attendance portal, I am having to go through these three checks, right? In either of these checks, if I am failing, the request will be sent back to me with an error, right? That I am not authorized or something, right? So these type of situations will warrant a chain of responsibility pattern. So there is some handler taking care of email verification. There is another handler taking care of password validation. There is another handler taking care of RBAC, right? So these are multiple handlers, and once all these handlers are through, I can access my company portal, right? So the request from the user is to access the attendance portal, but there are a bunch of handlers in between who can potentially return the request back to the user saying you are not authorized. And if everybody is passed, I get the actual HTML page that will render the attendance portal. So this is an example of the chain of responsibility pattern. We are giving more than one object a chance to handle the request, right? So we are passing the request along the chain until an object handles it. So we are passing the request along this chain until somebody handles it, right? So this is an example of the chain of responsibility pattern. Let's see some other examples. Let's say customer support. We are calling customer support and there is always a L1 support who will take care of the initial calls, and the customer executive at level 1 will decide if they can handle it or they need to escalate it to level 2 or to some other department, right? So that request is passed along to another department, and if that department can handle it, well and good, they will respond back to the user. Otherwise, the chain continues and the request is forwarded to another department or another level so that it can be validated and resolved there, right? So in this situation, we can see the chain of responsibility. And another example is approval workflows. There can be many corporate approval workflows that go through a chain of approvals, right? So let's say we are in the appraisal cycle and your appraisal has been initiated by you, and then it goes to your reporting manager, and the reporting manager can approve, can reject. If it's approved, it goes to the HR, they can approve, they can reject, and then finally it goes to the payroll, they will actually process the appraisal, right? So these type of workflows will demand a chain of objects, and each object is independent with each other and they can handle the request depending on their specific business requirements, right? So in these type of situations, we can see the chain of responsibility pattern. So these are some of the examples. Now let's see the actual implementation of this pattern. Let's go to UML now. So this is a class diagram representation of the chain of responsibility pattern. Very simple implementation actually. There is a handler, which is an abstract class, which is exposing two methods, set, next, and handle, right? And there is a handler in the private space, which is pointing to the next handler in the chain, right? So this is an optional thing. It will be default to null, and this will indicate the end of chain. If there is a next handler can be used as part of the chain, right? And this can be extended by handler A, handler B, handler C, and so on. Everybody will have to implement either the method as described in the abstract class, or they can override it and define their own methods for set next and handle. So set next is the method used for setting the next handler. So handlers are nothing but objects here. So this is an object of this class, handler class, right? So this is similar to linked list, where we are pointing one node to the other. Instead of nodes, we are pointing the objects of different handlers, right? And then there is the handle method, which will take care of the actual processing of the request. So if the main base class can handle it, it will handle it. Otherwise, it will pass on to the next handler. If this class cannot handle it, it will pass on to the next handler. If this cannot handle it, it will pass on to the next handler, and so on, right? So quite a simple implementation of the chain of responsibility pattern. Now let's see the sequence. So as you can expect, client will call upon handler A with the handle method. Here one of two things can happen. Handler A can handle it, it will process it and return back to the user, or it cannot handle it, it will call upon handle on the next handler, which is handler B. And handler B can repeat the same thing and it will return some response which will be returned back to the user. So this is a sequence of the chain of responsibility pattern. Now let's take an example of customer support. Let's say we have a support handler, which is our base class, which is an abstract class, and it is having a next handler and set next methods, right? And it is being extended by 3 levels of support: level 1, level 2, level 3. And there is a handle ticket method in which we will describe the logic whether to handle it here or whether to pass it on to the next level. And there is a common resolve method which can be overridden by L1 support, L2 support, L3 support, because they have their individual implementations of the same ticket, right? So let's say we are getting a ticket, and the handle ticket will check if it belongs to level 1, and then it passes on to level 1. If level 1 can handle it, it will call upon resolve and complete the request. Otherwise, it will call the next handler, which will be level 2. If level 2 can handle it, it will call resolve. Otherwise, it will pass on to the next handler, which is level 3, and so on. So this is how the chain of responsibility goes. Let's see all this in code now. So I am in VS Code now, and we have a new file, chainofresponsibility.cpp. This is our base class, the abstract class support handler. So it has the next handler in the private space, and it has the set next method to set the next handler, right? And then we have the handle ticket method, where we will check whether this ticket actually belongs to this level or not. For example, every ticket will go through L1, and if the ticket is L1, we will call resolve on L1. Otherwise, we will escalate it to next level and call handle ticket on that next handler. So again, in the next level, we will check it. If it is level 2 ticket, we will call resolve on it. Otherwise, we will call level 3 handle ticket, and so on, right? So this is where the chain is happening. And then we have the virtual method resolve, which will be overridden by each of those subclasses. Now let's see. We have L1 support, which is inheriting from the support handler, which will implement its own resolve method, and it is setting the level to level 1. So level 2 support class, it is setting the level to 2, and it has its own method to resolve. Similarly, level 3. Now let's see the usage. First, we have created the handlers, level 1 support, level 2 support, level 3 support. Now we are building up the chain. Level 1's next will be level 2, level 2's next will be level 3. So there are 3 handlers in this chain. And when we want to test the chain, we can create a ticket and pass it on to level 1. So if it is level 1, we have given the level as part of the function. So if it is level 1, this will be handled by level 1 resolve method. Otherwise, it will be escalated to level 2. For example, in this call, we are triggering submitting level 2 issue, which means we are creating a ticket with level 2, but we are calling it on level 1's object. So the ticket always goes through level 1, and we will check if it belongs to level 1. Otherwise, we'll escalate it to level 2, and because this ticket is level 2 ticket, it will be handled there. In the same way, we can call a ticket with level 3 through level 1. It will go through couple of escalations and then get resolved there, right? So this is the implementation of the chain of responsibility pattern. So let's run this and see. So as you can see here, when we submitted a level 1 issue, it was handled by level 1 resolve method, no problem. when we submitted level 2 issue, it got escalated to the next level, and level 2 handle resolve method has resolved it. And then when we submitted a level 3 ticket, it got escalated a couple of times, and then finally level 3 team was able to resolve the issue, right? So in this way, one of the handlers will resolve it and then return back to the user. So this is a code implementation of the chain of responsibility pattern. Now let's see some trade-offs. So with this pattern, we are getting loose coupling between the sender and receiver, obviously, because we are able to separate out the handlers through a chain, and the client is unaware of which handler is actually responding to it, and we are getting some loose coupling there. And we can also modify the chain dynamically. It's not that we have to build the chain upfront, because we are just pointing one object to the other. We can use some if-else statements to modify the chain and send the request in different directions. So we can get great flexibility here at runtime, right? And this also follows single responsibility principle, because each handler is independent of each other. Everybody is responsible for their own handling. And when it comes to weaknesses, it's a slightly complex error handling, because we need to keep track of where the request is going. It can go into multiple directions, and any handler may cause an issue, and that needs to be bubbled up back to the user in a proper way. And also there is no guarantee of handling, right? Because it can complete the entire chain without the guarantee of handling. So this is something we have to manage as programmers to respond back to the user in a proper way. So the chain is built, but each handler is just responsible for doing their own piece. But as an orchestrator of the program, we need to define how to handle it in case the chain is exhausted and there is still a request pending, right? So these are some things to keep in mind. Okay, that's it for this video, guys. We covered the intent, we've seen many examples, we have seen the UML diagrams, we have seen the code and some trade-offs. So if you have any questions or inputs, definitely put them in the comment below. Thank you so much for watching. Please leave a like if you found this helpful. Please subscribe to the channel if you haven't done already. Thank you so much for watching. I will see you in the next one. Cheers.